Alright, so what do we do today? So what were we doing yesterday? That's the question first. Do you remember? Yes?
Lines, angles.
Fractions.
What is that? Fractions, equivalent fractions, and then we started talking about the basic understanding of, yes, Aganya, you were saying something.
Area and perimeter.
Yes, the basic understanding of area and perimeter. We are not looking at any formulas, we are just trying to absorb and understand what are different types of shapes, what does it mean, what are the property of those shapes. And that should be deep rooted in your mind when you go to higher class. Okay? Let's say today when we talk about different shapes, I see kids thinking too much about whether a rhombus has all sides same, are they parallelogram, are the angles same as 90 degree or things like that. So that is where I'm trying to make sure that you guys are very clear about the basic understanding of properties of each and every shape that you come across. Okay? So that is what we are starting with. So we talked about what is area and what is perimeter. Area is the space taken by that particular object on the surface. Yep. And then we were talking about the size of the land that you have in India and how do you want to barricade it, and that will be the perimeter, right? So now let's look at again. So this is the space taken by this thing on this board is called the area. Okay. Now perimeter is nothing but the boundary. Meaning if I am trying to barricade this shape, or the length of the string or the length of the wall that I would need from here till here. So from the place from where I start till the end along the boundary, that is what is called perimeter. So perimeter is the length and area is the space here inside. This part is okay, right? No confusion? Okay. Now let's look at some basic shapes. How do we build our understanding around those shapes? That is here. Okay. Wait, slow. Just give me 30 seconds, okay? Yeah. You guys go ahead. I just want to, it's fine. I want to watch you guys go into the class. Okay. Now, let's look at what are the basic shapes. So when we talk about geometry, right? Something that you draw. Geometry is again a word that came from somewhere. I think from Greece. Greece and India are the two countries which has contributed the most for mathematics. Like the number 0. This number 0 is such an important one for maths. Though 0 itself has no value, but 0 plays a major role in mathematics. And do you know who invented 0? It was a mathematician from India named Ramanujan. So again, what I'm trying to say is, India and Greece are two countries where a lot of concepts of math have originated from. And that is how some of the terms that you will see, they will not look like English words. They have been borrowed from other countries, other languages and used in English. That's why they sound a little different. Okay? So geometry again, geo means surface or area and metry means something related with metering or measurement. So measurement of areas, that's what is geometry. Okay. So that is why this originated somewhere in Greece and then became a part of regular English that we speak every day. Okay. So that's why we will talk about a lot of different shapes when we learn about geometry. So let's look at something interesting here. Did we talk about this yesterday? We will see there are three things on the board. Did we talk about this yesterday? Did we? We did. So this is line segment, and this is called ray. Yeah, remember? Did we talk about this in the yesterday's class? Okay, we did. Then we'll not talk about it again. So line, as I would have mentioned, line is nothing but a direction which says, okay, this is going this direction, this is my one direction, this is my second direction. There is no fixed length, there is no starting ending point. It is just a direction. Right? So it's like, if you look at this road, I can as well say this is a line. This is just saying a direction. It might go very far that side, might go this far till the end. I'm not saying how big the road is. But if I say the distance between my house and my neighbor's house, that will become a line segment, because this is my house, this is my neighbor's house. Starting from my house, ending at my neighbor's house. And this length is fixed. I know probably it might be 100 feet, 150 feet. Yeah? So line segment is nothing but something similar to a line, but it has a fixed length and a starting and ending point. Okay? Wherein line only shows you the direction. Okay? Everybody clear about that? Difference between line and line segment? In normal usage point of view, we don't differentiate. Okay, you will see everything. Okay, I have one line like this, second line this, third line this. These are not lines actually. These are line segments, pieces of line. Because line is something which has no end. It's a direction. Then these are lines now. But if I say I'm making a triangle, I'm not making it with line. I'm making it with line segments, because I have fixed length of these shapes, a starting ending point. That is why these are line segments. But when we use it, we don't really care much. You will see a lot of people, including me, we say, okay, I have 3 lines making this circle, triangle. Okay? But actually, grammatically, mathematically, this is the right definition. Alright? Everybody with me? And then we talked about ray, where I would have shown you guys my old phone. Yeah? Alright. So, okay, so let's leave it now. Let's move on. Now, we talked about one line segment and ray. What happens if I take 2 things together? This line, now this is a line, I have a row, there is no fixed length. And this line. Or this line segment and this line segment. What is happening here? They are leaning against each other in a certain way. Right? If you see the wall on which this is hanging right now, if you look at the basement of this one, right? Look at this. This is the basement. This is the base part, right? So against the base, this is my base, the surface on which I am standing and taking the class right now, and this is the wall. So here, this base and this wall is related to each other in a certain way. Yeah? Leaning against each other in a certain way. At a certain slope. Yeah? Here, there is a slope. It looks like this wall is falling. Give it some more time. It will be here. Yeah? So this is the inclination at which the 2 line segments or lines are related to each other is called angle. Okay? So here you say this is a perpendicular thing or 90-degree angle. Meaning this and this line are meeting each other vertically. If my wall is leaning against my surface like this, that means I should not be living in this house. It's going to fall soon. Yeah? So this is the angle. The way the 2 line segments are leaning against each other, that is called angle. And there is a way to measure that in mathematics. Okay? So, for you guys to understand the basic thing, one thing that we see around us always, like the 2 walls, vertical walls. This is my floor against which this wall is there. Look at your room, look at your roof, look at the base. You will find everywhere it's 90 degree. It's vertical. is like this. You will not see like this. Okay? Look at every corner of the house, the room. You will see that they are like two lines meeting each other like this. Do you see that? Do you guys see that? Yeah? So when you have two lines meeting like this, perpendicular to each other, this is called 90-degree angle. This angle is 90 degree. Okay? Meaning, if you have you guys seen something like this, like a semicircle, which will have lines drawn on it? Do you guys know what is that called? Have you guys seen this something like this? No? What is that called, Shalini?
I kind of forgot the name, but
I think it's called projector.
yes, something
Projector,
like that.
right? Yeah. So Vaibhav must be having one. Srivatsav also must be having one. So just ask them to show it to you one more time, and you will see that this one is like a semicircle, okay? Where you will see numbers, different lines drawn here, 20 degree, 30 degree, 40 degree, 60 degree, until here it will be 180 degree. Okay? So if you look at the one in the middle, this will say 90 degree. Here you will see 90 degree. This is nothing but the 90 degree that I was talking about. This angle you can measure using the projector, okay? So if you are looking at, let's say if you have two lines like this, and you have to find out the angle between them, you will move this projector from here, place it here. This horizontal line aligns with this one, and this center falls on this one. And then you will see this line is touching here or here somewhere. Let's say if it touches here, it's maybe 40 degree. So this projector is just a tool that you can use for measuring the angles. Okay? Or angles is nothing but the way two lines or line segments are leaning against each other. Okay? So when the lines are vertical or perpendicular to each other, this angle is called 90 degree, or this is called right angle. Do you know why it is called right angle? Because if my wall is like this is the right angle. If my wall is leaning against my base like this is not the right angle. This is the wrong angle. So that's why this perpendicular wall, the vertical wall, is the right angle. This represents that yes, your wall is in the right place. If the wall goes like this or goes like this, that means there is a problem. Run out of the house immediately. Okay? So if the wall is leaning against each other like this, then you are in the right place. The angle is right. You are safe. Okay? So that could be one of the reasons why they term this 90 degree as a right angle. Okay? I just gave you guys a very lame example so that you can remember it. Okay? If my wall is like this, then the angle is right. The wall is right. There is nothing to worry. If the wall starts leaning against my bed, getting closer to the bed, and it's not 90 degree, there is a problem. Either leave the room or leave the house. Yeah? Right? So that's why if it is perpendicular, if it's vertically straight, that angle is called 90 degree. And when you look at the projector, you will see this vertical line being 90 degree marked. Okay? This part is clear so far?
Sir, people say something like a circle is like a 160 or a 180.
No, circle is 360. We'll come to that. Okay? So, very simple, right? I was saying that your projector that you would have seen at home, it will be like a semicircle, and it has from 0 till 180 degree. So this is semicircle, half of the circle, and it's making 180 degree. If you complete it, what will be 180 plus 180? That is how it becomes 360 degree. So a circle is 360 degree. The projector that you use, that you see is half of the circle, and that you will see 180 degree marked. Okay. So Jaganya and Salini, you both would have seen projector at home because your elder sibling Must have seen it. So Aditi, you might ask your daddy to buy a protector for you, okay? Then you can see the angles there, okay? I believe you don't have anybody elder to you, right at home? You don't have an older brother or sister, right, Aditi?
No, they're in Charlotte, in North Carolina.
Ah, okay. So basically what I'm saying is, you if you don't have a protector at home, you can ask daddy to buy one so that you can see the angles and you can relate to what I'm saying right now, okay? Yeah? Okay. Alright, yeah. Somebody is saying something. Who was it?
It was accidentally nothing.
Ah, okay, not a problem. So we just looked at the lines or line segment leaning against each other, and if they are vertical, if they are at 90 degree, they are called that this angle is called 90 degree or right angle. Now look at a situation like this, where this angle is less than 90 degree, let's say 70 degree or maybe 60 degree, okay? When the lines are not perpendicular to each other, meaning they are closer to each other, closer, less than 90, angle is shorter, smaller, okay? Anything that is small, do I look cute anymore? No, I don't, right? I'm not small anymore. I'm grown up. So things which are small are cute, right? So here the angle is smaller than 90, smaller angle, a cute angle. That's what it is called. So when you are looking at the 90 degree angle, that angle is right, your wall is not falling, that is called right angle triangle. That is called right angle. If my angle is less than 90, that is small, that is less, that is cute, it's called acute angle. Acute angle. Now imagine a situation like this, when your lines are, or line segments are far from each other. Far as in, this is one line segment and this is second line segment. Look at this. If this was straight, that would have been 90 degree. The wall is falling on my neighbor's wall. This is not falling towards me, this is falling on neighbor's wall. More than 90, right? My neighbor lives here. This is my bed, this is where I'm sleeping. See, this wall is not falling on me. This wall is falling on my neighbor's wall. But mathematically, what do you see? This was 90 degree and this is more than 90. If you look at this compass, predicted that I was talking about, here it is 10, 20, 30 and here it is 90. Here you will see 100, 110, 120 and up to here becomes 180. So here you can see this is more than 90. Big. Bigger than right angle. It's called obtuse angle. So there are three types of angles that we talked about. Let's look at it. Let's put it here on the board. When the angle is 90 degree, meaning the two line segments or lines are perpendicular to each other, equal to 90 degree, is called right angle. This angle is right. We don't have to worry. The wall is not going to fall anytime soon. Neither on me nor my neighbor's house. Okay? This is right angle. If the angle is smaller, meaning the lines are closer to each other, okay, and making an angle smaller than 90. It could be 5 degree, it could be 10 degree, it could be 85 degree, it could be 89 degree, but lesser than 90. Meaning these angles are smaller, cuter. And I know I keep on giving all lame examples. The reason is you should be able to relate. Okay? Which movie you guys like? The movie which has a lot of nonsense thing, right? No serious talk. Imagine watching a movie where somebody comes and talks about a science class. You will not go for watching that movie, right? You will go for watching a movie where you get entertained. Something which is very light. So that's why I keep on giving you guys very lighter, entertaining examples, even if that sounds lame at times. But it will be easy to relate. These angles are small, acute. So an angle which is acute angle. So right angle and acute angle you will not forget, because that is relatable. Now something that is bigger than 90 degree, meaning when the lines are much farther, the angle is much bigger, or the angle is greater than 90 degree. It's called obtuse angle. So look at this. Right angle, acute angle, obtuse angle. So this sounds, phonetically it sounds opposite to acute. Acute angle, obtuse angle. Yeah?
Yeah.
So,
So,
yeah, yes, better.
fun fact.
What is that?
Fun fact. Acute angle is like a acute angle.
Acute angle, that's what I said. Acute angle, or an angle which is small, cute. Acute angle. This guy is looking bulky, big, obtuse angle. Yeah. Yeah? Alright. We looked at line segment and rays. Then we looked at what happens when I have two lines or line segments dealing with each other. When they are leaning against each other, what happens? We call it, they lean against each other, they make certain angles. Or the leaning or the relationship when they are leaning against each other is called the angle. When they are okay. So when they are meeting each other in a perpendicular way, meaning they are vertically aligned like this, like a wall against my floor, that is right angle. The angle is right. It's smaller than this is acute angle, and when it's looking bulkier, big, huge, or obtuse angle, meaning greater than 90 degrees. Okay? This part is clear, right? So far, no doubt. Okay. Now, let's look at one more thing. Since we are talking about two lines or line segments meeting each other here and making the angle. Yeah? If you look at it carefully, let's say this is my line AB and this is my line CB. Okay? They are meeting each other at point O. Okay? They are bumping into each other here. Now, what do you see? Here, they are making this angle. AB and CD is making this angle. Also, they are making this angle also. If you see this, AB and CD, they are making this angle also. Yeah? Do you see that? So, basically, in a summary, you can say when two lines cross each other or line segments cross each other, they make four angles together. 1, 2, 3, and 4. Okay? If you look at it more carefully, you will see that angle 1 and angle 2 are same actually. They are called opposite angles. When you have two lines crossing each other like this, these angles are called opposite angles. Shalini, don't play with that, beta. You are drawing my attention, so then I get distracted. Okay, alright, come here. So when the two lines or line segments cross each other here, these angles, they are called opposite angles. And they are actually same. Why? Look at this. This is how they are aligned. This is how they are aligned. Okay? So this is a homework for you guys. When you buy that or get that protector, draw two lines, okay? Just draw two lines using scale. And measure this angle and measure this angle and see if they are same or not. Okay? Alright? And let me know if they are same or not. This is a proven theory where when you have two lines crossing each other, the opposite angles are same. This angle and this angle will be same. This angle and this angle will be same. But this is a homework for you guys. Make sure that you all have protector at home. If you don't have one, buy one. Ask daddy, mommy to buy one for you. This will be like a probably 50 cent or $1 thing, okay, not more than that. Okay? And make two lines, draw two lines and measure the opposite angle, see if they are same or not. Do it 4-5 times. And if you ever come across a situation that the two opposite angles are not same, that means either you did not draw the line right or the protector was not right. Okay? It has to be same. That's a property that we need to know. Is that okay? Everybody okay with whatever I said? Yaditi? Okay, good. Now, so we have looked at.
So, is it like this?
Yeah. So when you are drawing two lines, draw it with a scale, not with a hand. Okay. You draw it with a scale so that they are exactly perfect line, and then you measure the opposite angles using the protector. And if any of the opposite angle pair is not same, then let me know. Okay, they have to be the same. That's the property of the basic property of geometry that we learned. All right. Now, so we talked about line segment rays. We talked about line or line segment leaning against each other, making angles. Then we learned about right angles, acute angle, obtuse angle. And then we learned about when two lines cross each other, the opposite angles are same. That's an assignment for you guys. You will draw multiple lines and see if the opposite angles are same or not. If you see any problem, you will let me know. So, these are the things that we have learned so far. Now, I want you guys to learn two more things. One is called parallel lines and second is called beginning of learning polygons. So let's start. Okay. So now let's look at and if you guys don't take notes while I'm teaching, that is perfectly fine. Okay? Because if you are spending a lot of time taking notes, you might not be able to pay attention in the class. So if you don't take notes, that's perfectly okay. Because I'm anyways uploading the video of the class for you guys only to consume, right? I'm not a YouTuber where lots of people watch my videos. It's only my kids who watch my videos, okay? And it is meant for that only. So, even if you're not taking notes, that's perfectly fine. Look at this. I have two lines. I'm calling them parallel lines. These lines are parallel to each other. Do you know what does it mean? Or have you seen parallel lines around you? Yep, yeah, you can hear. You have seen parallel lines? We see parallel lines everywhere. Look at the window, Aditi, right next to you. If you look at the edge of the window, right? The two edges of the window, they are parallel to each other. Okay? Look at the wall. You will see that there are the two ends of the wall. Even look at the board. This and this are parallel lines. This and this are parallel lines. Okay? What Chalini is showing, that is also a parallel line. To this side. Even your notebook where you are writing things, your notebook doesn't look like this. Your notebook doesn't look like this, right? Your notebook looks like this. Yeah? So this and this are parallel lines. This and this are parallel lines. Another classic example of parallel line is the railway tracks. Who all has taken a train for going anywhere? Who all has seen the railway station? Aditi, have you been to a railway station before? Yeah?
Yeah. I went there
Last year? Okay.
At 2021 when I was two.
Okay. Okay. Yeah. Charlie is showing me the railway track. So everybody has seen a railway track, right? Now, how does the railway track look like? You will see something like this. And this just continues, right? What is the thing that we have to keep in mind? When you are having a railway track like this is where the wheels are, right? This is where the wheels roll, right? Of the train. Yeah? And the distance between the wheel is fixed. So tomorrow, if my railway track becomes like this, do you guys know what will happen? If I have a railway track like this, and the train goes from here to here, do you know what will happen?
They will crash.
They'll crash. There will be an accident. And to avoid that accident, what we have to ensure? The distance between the two tracks always remains fixed. This has to remain fixed. Yeah? The distance between the two metal plates has to remain fixed. That is the property of a parallel line or a pair of parallel lines. When we say there are two lines parallel to each other, what does it mean? The distance between the two lines is fixed regardless of how far you go. Be it here, if I keep drawing the line on my wall again, the distance between the two lines will remain fixed. That is what is called a parallel line. Okay? So, a pair of parallel line means there are two lines where at every point that you pick, the distance between the two lines will be same, exactly the same. Or in mathematical terms, you will say the perpendicular distance between the two lines. So we are talking about this distance, not distance like this. When the lines are straight, this is called perpendicular line. So you are measuring this distance, not this distance. Okay? That's why it's called perpendicular line. Okay? Everybody with me so far? Okay? Now look at this. So we learned about the parallel lines. So see, we started learning with the angles where the lines were meeting each other at certain angle, with certain relationship. That was called angle. That is where we learned about right angle, acute angle, obtuse angle. Here we are talking about two lines and we are saying that don't make them meet. If they meet, there will be a train accident. That is what is a parallel line. Where the perpendicular distance between the two lines always remains the same. Whether you are measuring it here or you are measuring it in this corner. This will be the same everywhere. Okay? So that is the property of parallel line. Now, there is one more thing that I would want you guys to know or try to relate. Let's say these are two parallel lines and then I have a third line that crosses both of them. Do you know what this guy is called? This is called a line that is intersecting both the lines. So this is called intersecting line. Okay? And from parallel line, what we know is the corresponding angle. This angle and this angle will be same. These are called corresponding angles. Why? Look at this. These are two parallel lines and these two angles are on this side of the line, intersecting line. And this is above this line and this is above this line. They are called corresponding angles. Okay? Likewise, so this is one and this is one. These are one and one is called corresponding angle. Similarly, 2 and 2 will be called corresponding angle because both are above the parallel line and on the same side of the intersecting line. Okay. Similarly, this and this will be called corresponding angle because both are below the parallel lines and on same side of this intersecting line. Similarly, 4 and 4 will be called corresponding angle because again they both are below the parallel lines and on the same side of the intersecting line. So only this much you need to know about parallel lines for now, okay? And trust me, not many kids in your grade would probably know about the name of these angles, okay? So this is just for you guys to understand and relate. So, okay, we saw the angle, lines meeting each other at a certain angle. Then we saw, okay, what if they don't meet? They are called parallel lines, where the distance between them remains the same. There is some more property that we are learning. If I have two parallel lines and there is a third line that cuts across both of them, these are called corresponding angles. 1, 1, 2, 2, 3, 3, 4, 4. These are called corresponding angles. And here are the magic words. Corresponding angles are same. Meaning, if I have two parallel lines and there is a third line intersecting them, this and this, 1 and 1 are corresponding angles and their value will be same. So if this is 45 degree, this will also be 45 degree. 4 and 4 will be same, they are corresponding angle as well. Let's say if this is 135 degree, this will be 135 degree. This is only for you guys to relate, okay? Don't rush, don't stress out. Don't get stressed out, okay? Because these are things that you will learn in detail. I'm just telling you guys about certain properties that you need to be aware of. That if I'm talking about lines, this is what it is. This is one line segment. Two lines meeting each other at certain angles. What if the lines don't meet? They are parallel lines. What if there is a third line cutting both of them? These are called corresponding angles. Okay? And corresponding angles are same. If you know this much, more than enough for you guys for now. Okay? So, let me stop here. Any questions with respect to whatever we have learned so far? Yes, Aditi.
I want to say that a computer also has parallel lines.
Yes. Yeah. Your computer, your laptop, your keyboard also mostly. Yeah. So one thing, beta, okay, for all of you, okay. When I try teaching you guys something, okay, any type of shape, always think that have I seen something like this? Tomorrow if I teach you circle, you will not say that my face looks like a circle, right? It doesn't look like a circle. But if I flip my laptop a little bit and show you guys the light, let me show you guys the light here. If you look at this light bulb, does this not look like a circle? It does. So this circle and my face, like a circle, is a difference. My face is not like a 100% perfect circle. This is very much a circle the way I draw it. Yeah? Alright. Now, on a serious note, when we talk about any shape that we see, right? Always try to relate. Have you seen something like this around you? Let's see if I talk about a triangle. Have you guys seen a triangle around you? There will be many triangles, right? Let me see if in the classroom I see any triangle right next to me. See, I am trying to find a triangle. I could see one here. Look at this. They have drawn a triangle here, right? So, if I am learning about triangle, I am sure that I will come across this in my surrounding as a normal human being, not as a mathematician. As a normal person, there will be something that I will see which will look like a triangle for sure. Yeah? I have seen girls having earrings also look like triangle nowadays, right? I have two daughters. I have seen one of them wearing a earring like a triangle, okay? So anyways, so coming back to what I was saying was that any shape that we learn, always try to relate and see, do you see anything of that sort around yourself? Is that something that you can relate to? Right? Is that a shape that you're learning and you'll end up forgetting for the rest of your life? So that is why if you find something relatable, if you find something in your surrounding, if you see something that you have seen and experienced and then you're learning about the property of it, at least you can relate. Tomorrow, if let's say if you learn about a circle and then you see your dad's car, oh, I can find out the area of the circle, right? How big is the tire? Is it this small or this big? If this is this big, how much is the area? If this is this small, how much is the area? Or the perimeter. Let's say if you want to put a sellotape around the tire, don't do that. That's not a good idea. I'm saying if you want to cover your tire, how much of perimeter it is. If you know how to find it out, then you can use that understanding or knowledge for finding out how big a piece of cloth you would need for covering your tire. Right? So always, whatever we learn, always try to find out how you can relate that with what you see in your surroundings from a practical perspective. Not only something that you learn in the class, write in the examination hall and forget about it. Not that way. Anything that we learn and we end up using that in our day-to-day life, that is when that becomes your concept. You don't have to memorize it. Okay? So, coming back to this point. Okay. So, whatever we have learned so far, that is what we did a recap for. Now, the next thing that we are going to learn, I will only take 5 more minutes, okay? Then I will let you guys go. Today, it could be a smaller class because it's Sunday, and I know you guys are a little worried about your school starting. All the fun that you used to have, sleeping late hours, now that will be gone. You have to wake up on time, get ready for school. Yeah, that's where you guys will feel a little worried, and I will feel happier because I'll see more discipline. Yes, Salmi, you're saying something.
And also, why did you put the class on 6 p.m.?
Only for today, because today is my younger daughter's birthday. So I had to take her out for certain things. In the afternoon we had some of her friends coming over. So that's why we thought we'll change the timing only for today, okay? Going forward it will remain the same time, okay? You guys have your class at 4 p.m. It will happen 4 p.m. only, okay? Only for today. Yeah?
Happy birthday to her.
No, I'll certainly convey that, okay? So she is also very happy like you guys, getting ready for school. She is raising concern, saying, no, I have to wake up so early now because the school is starting. Yes, Aditi?
Happy birthday to you and your daughter.
Thank you, beta. Thank you so much.
Welcome.
Yeah. All right. So here, we looked at angles, we looked at parallel lines, and did you guys observe something? It is open. If I look at angle, it is open. You cannot lock the door. Any burglar can come inside and steal the things. Yeah? Parallel lines is also open. Any stranger can come from here, come from here. So, but from this, what we can relate is, if you have only 2 lines, you cannot close it. With 2 lines, you cannot create a closed shape. You need at least 3 lines to create closed shapes. That is what is called triangle. Yay! No, that's what in the previous class, if I say something, one of my students says, yay, I learned triangle, and then he starts dancing. Okay, so summary is, if so far we have seen only closed open shapes, now we are going to learn about the closed shapes. And for creating any closed shape, you need minimum 3 sides. Minimum 3 sides. This is a closed shape. 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 This is a closed shape.
Dot has trapezoid.
No, not yet. None of them are trapezoid. So, these are the closed shapes. What I'm saying is, these are the shapes which has minimum 3 sides. That is how we are able to create closed shapes. This is closed shape with 3 sides. This is closed shape with 4 sides. This is closed shape with 5 sides. This is closed shape with 6 sides. This is closed shape with 7 sides. This is closed shape with 8 sides. This is called triangle. This is a closed shape with 4 sides called quadrilateral. Quadrilateral. Again a Greek word. Okay? And within quadrilateral we learn about rectangles, squares, rhombus, kite, parallelogram, trapezium or trapezoid. But that is inside the big family of quadrilaterals. Quadrilaterals meaning a shape with 4 sides, and depending on different properties, we learn about different shapes that I talked about. Then this is a shape with 5 sides, that is called pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon, nanogon, decagon, and you can just go on. But there is one common term that you can use always, saying polygon. Poly means many, gon stands for side. Again borrowed from Greek. Polygon means any shape with multiple sides. So like I was saying, quadrilateral has 4 sides, and depending on different properties you can have rectangle, square, parallelogram, rhombus, kite, trapezium, everything inside the big family called quadrilateral. Likewise, polygon is the big family which includes every shape with more than 1 side, essentially more than 2 sides. Okay? Because there is no shape or there is no closed shape with less than 3 sides. So polygon stands for shapes or closed shapes which has 3 or more sides. Okay? Poly stands for many. That is the high level view I wanted you guys to understand. So look at the journey. Look at the journey. I'm telling you a story, right? I started with one line, ray, and line segment. Then we say, okay, how about 2 lines or line segments? Then we have angles. If we are not making angle, there are parallel lines. Then we say, okay, how about 2 becoming 3? That is when we got triangle. How about becoming 4? Got quadrilateral. How about 5? Pentagon. How about 6? Hexagon. How about 7? Heptagon. How about 8? Octagon. How about many? Polygon. Yeah? So it is still a journey, right? If you have to teach somebody, let's say you catch hold of a toddler, a 4-year child, would you want to tell that guy, okay, I will tell you the formula for trapezoid? That guy will never talk to you. What you would do, if you want to explain him or her something, you say, okay, fine. See, do you see one line? This is called line. That is 1 day class. Done. After 5 days, when you play with the toddler again, you'll say, okay, now we'll deal with 2 lines. See, these are 2 lines. Having some relationship with each other. This is called angle. Done for the class. So, what I'm saying is, you have to have that story in your mind. How is this evolving from one line to this kind of shapes? And then, when you go to next level, when you cannot really count the number of sides, that is when we come across circle. Yeah? We'll stop here. Any questions so far? No questions? Aditi, Yaganya, Kasvik, no questions? Everybody is good? Everybody is all charged up for school to start? I know next weekend you guys will not like me if I ask the same question, because it will be just before the school start. But it's fine. See this. I know it's a change. We have gotten used to certain ways of living for last 2-3 months, give summer break. Now when the school starts, there will be a certain change. But while you might be having your worries in place, but be excited about the fact that you are going to meet a lot of friends again. right? At home you stay, whom do you meet? Your mommy, daddy and your siblings, that's it. Go to school, you'll meet 20 friends, everybody of your age, right? Everybody thinks like you. Everybody is equally playful, equally energetic like you. That is what you should be happy about. Okay?
Yeah, I'm very happy about school because I don't need to waste my time around.
Yep, no, true. I mean, you have to go out. You have to go meet with your friends. You have to go have fun with them. You have to go study with them. You have to go spend time with them, see what they are learning, what you are learning, and then get best of what you can get from your friends. Yeah. So have fun. Enjoy the rest of your evening. We'll meet again next Saturday. I'll upload the video of the class so that you can, if you want, you can revise, and then I'll send you the assignment also by tomorrow or day after, and then you can have fun with that. All right.